Today, I have the great honor to be joined by Thomas Seyfried. He is a professor of biology, genetics, and biochemistry. He has spent 40 years researching cancer. He is the author behind over 150 papers and the book Cancer as a Metabolic Disease. So it's a great honor to have you on this podcast, and I'm so excited to share this very important information about your research and findings. But before we dig into all that, let us start here. Cancer has become extremely common. We all know someone who has had cancer. So I want to start off by asking, where are we at with the war on cancer? Are we winning this war, or how is the situation here?
Yeah, well, thank you. Thank you, Sil. It's very nice to be here and speak with you. No, we're not winning. We're losing. We're losing miserably. As you said, all Western societies, cancer is increasing. Not only the incidence, but the death is increasing in all major Western countries, and it will continue to increase. The projections are bleak, and it will overtake heart disease at some point. Already in China, cancer has already overtaken heart disease. In our country, the United States, we have about 1,000, almost 1,700 people die each day from cancer, which is about 70 people per hour dying from cancer in the United States. So, and I know there's an increase in other European and countries as Far Eastern countries, China, Japan. So the answer to your question is no. We are not winning the war on cancer, and we are losing, and we are not making any major advances.
And as you were saying, this is happening in the Western societies. And this tells us something. It tells us that we're doing something wrong. Not only cancer that are rising in the Western societies, but also chronic diseases are going up at the same speed. So, what are your thoughts on that? It seems to me that there is a link here.
Yeah, there is a clear link. It's diet and lifestyle predominantly. Um, so, as I said, the great American diet and lifestyle is now permeating the entire planet, and what that brings is chronic diseases, type 2 diabetes, cancer, dementia, coronary artery disease, all the kinds of hypertension, high blood pressure. Diet and lifestyle. And what I mean, well, the diet and the lifestyle is less exercise. I think our technology throughout the world has provided us with so many conveniences that we are not as active as we were, say, 100 years ago in the Western societies. We all had more activity. We did not have as much highly processed foods. The world agronomy is providing foods for around the world, but many of these are packaged and processed. And I think it's a combination of less exercise, and more consumption of processed foods rather than natural foods that would be grown naturally in the farm or on your backyard or something like this. So I think you put that together. Now there might be some push from chemicals in the atmosphere, but I don't know what to say about how important those are. I think in my mind it's the diet and lifestyle based on our advances in technology that are putting us at risk for chronic disease, including cancer.
And would you please tell us a little bit about, like in more detail, what is cancer? Like, what is the difference between a regular cell and a cancer cell? Because I think that is important to understand before moving on.
Well, cancer is simple definition. It's cell division out of control. So that's basically the definition. Dysregulated cell growth. So in all of our tissues and organs, we have cells that are made up of individual cells. And each one of those cells in the organ is performing a function according to its genetic program. And cancer represents a situation where the cells, a particular group of cells in a particular tissue or organ, begin to grow in a dysregulated way. So the difference between cancer cells and normal cells is that normal cells are behaving according to their normal program, whereas cancer cells are dividing out of control. There are many differences between the tumor cell and the cancer cell with respect to mutations and things like this. But the main difference between the cancer cell and the normal cell is the way the cell gets energy, how it gets energy. And the normal cell is respiring because we're all breathing air, and that air has oxygen, and the oxygen comes into the body and is used as an acceptor of electrons to allow us to produce energy very, very efficiently in the organelle of the cell called the mitochondrion. Cancer cells have defects in these organelles, the mitochondrion, thereby failing to produce enough energy through respiration, forcing the cell into a fermentation. In other words, energy without oxygen. And I think that's one of the great differences between normal cells and cancer cells. Normal cells need oxygen to remain alive, um, and grow when growth is when growth becomes necessary. The cancer cell can live and grow in the absence of oxygen. So that's called energy without oxygen. That's called fermentation. And the loss of that capability causes these cells to grow out of control because the organelle that controls the quiescent or differentiated state is the mitochondrion. And when that organelle becomes damaged in some way, losing its ability to get energy from oxygen, the cell now starts to grow out of control because the regulatory system, the organelle itself, is defective, and the cells fall back on ancient pathways of energy and just dysregulated growth. So that's the difference, predominant difference.
Okay, and is this correct that the higher your blood sugar are, the faster the tumor grows?
Yes. This has been we did studies on this ourselves. We were one of the first groups to do this in preclinical systems using linear regression analysis, holding glucose as the independent variable and tumor growth as the dependent variable. And we tested mice under a broad range of diet conditions, restricted diets, high carb diets, ketogenic diets, and what have you. And what we noticed in no uncertain terms is that the higher the blood sugar, the higher the sugar in the blood, the faster did the tumor grow. The lower the sugar in the blood, which is glucose, the slower the tumor grew. And then when others tested this in humans, breast cancer, brain cancer, colon cancer, all the different cancers, the same linkage was found that the prognosis was worse and tumors grew fastest when humans' blood sugar was highest and could be slowed down when blood sugar was the slowest, low when it was low. So we see the same relationship in the mouse and the rat and the human. Basically, if people want to slow the growth of their tumor, they need to maintain low blood sugar. If for whatever reason they want to increase the growth and speed of their tumor, they would have to raise their blood sugar as high as they can get it. And that would show them in no uncertain terms what's the effect of this. And we have seen this in patients where you can actually see the tumor growing faster in direct relationship to how high the sugar is in the blood.
With that in mind, did you know that in Sweden we are literally giving patients sugar while getting cancer treatment? Is that the same in Boston?
Oh, same almost everywhere. Um, because what I just said is not known by the majority of oncologists. So if they are not knowledgeable, then they do things that are not in the best interests of the patient's outcome.
Let's talk about cancer as a metabolic disease because today we look at cancer as a genetic disease, right? But you're saying it is a metabolic disease. Would you please talk a little bit about this?
The cancer cell uses a different form of energy than the normal cell. It uses fermentation metabolism without oxygen. This is because the organelle controlling the metabolism of the cell, the mitochondria, is defective. So we have not found any cancer cell that has a normal number, structure, and function of mitochondria, the organelle that controls the metabolic parameters within the cell. Um, so when you have that's the common metabolic phenotype or condition seen in all major cancers. Okay, all major cancers have the same problem. Um, but every cancer may be very, very different with respect to genetic mutations. So even within the same tumor, uh, you have many different tumor cells, and each cell will have a different composition of mutations than any other cell. But every cell in that tumor has defects in energy metabolism, thereby making cancer a metabolic disease. Now, the mutations are not the cause of dysregulated cell growth. They're the effects of the dysregulated cell growth. So here, when that organelle, the mitochondria, becomes dysfunctional, it produces reactive oxygen species. These are carcinogenic and mutagenic. They are radical oxygen species that cause mutations and chromosomal abnormalities in the nucleus and in the DNA. So, what that means is that the corruption of mitochondrial metabolism precedes or comes before the mutations that you see in the nucleus, making the mutations not the cause, but the effects. And the great tragedy, and the reason why we're not making any advances in cancer, is because the majority of cancer researchers in government and in academic and pharmaceutical organizations are focusing on downstream effects rather than the real issue, which is energy metabolism. So that's why cancer is a mitochondrial metabolic disorder caused by damage to oxidative phosphorylation in the mitochondria, which then leads to a compensatory fermentation, dysregulated cell growth, and nuclear gene mutations, all of which are downstream. So now we know from many, many studies that normal tissues in our body that do not have dysregulated cell growth have many different kinds of genetic mutations, driver mutations, and yet they have no dysregulated cell growth. We also know of some cancer cells that have no mutations and yet grow out of control. So we know this. And then when you put all this together with the nuclear mitochondrial transfer experiments that were done, it becomes no longer credible that cancer can be considered a genetic disease. It's a mitochondrial metabolic disease that cannot grow without fermentable fuels. And we and others have shown that those fermentable fuels are the sugar glucose and the amino acid glutamine.
Thank you for that, Professor Seyfried. So, okay, now we have some background information about what cancer really is and where we're at with the war on cancer. Would you please tell us about how you treat cancer patients in a non-toxic way and without the horrific side effects of chemo and radiation, and what the results of the treatment are?
Well, the reason why we continue to treat cancer patients with radiation and chemo and surgical mutilation and these kinds of things is because the promise of the genomic studies have not been realized. Most nations around the world, including Sweden, have put in billions, hundreds of millions of dollars into studying cancer genetic changes. And as I said, this has not led to any major advances in reducing the death rate in cancer patients. And so we continue to use toxic medieval therapies because the promise of the genomic studies never came. So we continue to use medieval therapies for cancer because what we thought was going to bring us out of this medieval approach never happened. And that's because the theory under which cancer is viewed is not correct. It's not a genetic disease. So we're never going to make optimal treatment conditions based on the wrong theory. So consequently, we must continue to brutalize cancer patients with these, as I call them, toxic medieval kinds of things, massive radiation, poisoning with chemicals, surgical mutilation, and even the newer therapies, the immuno-oncology therapies, which are supposed to have the big breakthroughs, are not happening because they're based on the incorrect theory. So, but once we realize that this is not a genetic disease, but a mitochondrial metabolic disease, then the strategies become very clear and non toxic. For example, we have not yet found any tumor cell that can grow in the absence of the glucose and the glutamine. So when we take those glucose and glutamine away, all the cancer cells will die. The cancer cells cannot transition, they have no flexibility. They cannot transition to fatty acids or ketone bodies because the organelle required to use ketone bodies and fatty acids for energy is defective. So we know the cancer cell is trapped into this fermentation energy, energy without oxygen, driven by only two major fuels, glucose and glutamine. And they have an inability to use respiratory fuels like ketone bodies and fatty acids. So the non-toxic strategy, which will eventually become the standard of care, will involve the simultaneous restriction of the two fuels driving the dysregulated cell growth while transitioning the entire body to fatty acids and ketones, which the tumor cells cannot use, but which the normal cells of our body use to become strong and healthy. So as we slowly degrade the tumor, we are making the rest of the body strong and healthy. And the stronger we make the normal cells and the weaker we make the tumor cells, the body will eventually purge and eliminate the tumor cell from the body without toxicity. But the patient themselves must play an active role in this non-toxic strategy. They must know what to do and how to do it. And we have published and are publishing the strategies for which both patients and their caregivers can follow the non-toxic procedure for the gradual elimination or indolence of the tumor.
That's wonderful. And for how long have you been doing this treatment? And do you have any idea how many people have survived because of it?
Here's the situation. We have done all this work in our preclinical systems, and then we modified the approach for people. And I've published many case reports on individuals that should have been dead, were given terminal diagnoses, and they're all doing very, very well. They have a high quality of life. And I'm not saying they're cured. All I'm saying, maybe some are, maybe some of these people are. But there's others that are not, but their tumor is now indolent. It doesn't grow, and their quality of life is good, but they still have this tumor in their body, but it's no longer considered a terminal kind of situation. Maggie and Brad Jones are almost through with their big documentary on the cancer revolution, which shows that cancer is primarily a metabolic disease, and they have been collecting numerous folks who are supposedly terminal cancer patients that are all alive with all different kinds of cancers: lung cancer, colon cancer, breast cancer, brain cancer, all the different kinds of cancers that were all given terminal diagnoses, and they're all still alive. And you can go to their website and see interviews with all of these different patients. And I keep sending them more and more people who email me telling me that they were supposed to be dead and now they're alive. And what I tell them is go to Brad and Maggie, they will interview you, and then you can tell the world what you did and how you did it to manage your cancer. How many people will it take before the world recognizes that this is the way to manage cancer? A stumbling block is the people say, well, we can't believe it. We can't believe that these people are real until we do a big clinical trial on your therapy. The problem is most of the people who won't believe it have no clue about the problem. They don't understand the biology of cancer. And if they try, some folks have tried to do clinical trials, and they do it in the absolute wrong way with no knowledge about how to. This is a new medical treatment strategy. Training is involved. You have to be knowledgeable to do a trial. And besides, the strategy of clinical trials for metabolic therapy is completely different than the trials for some drug produced by the pharmaceutical industry. Each person must be viewed as a separate entity. The person is their own control. So we have to go on their status. If you're diagnosed with cancer and you have quantitative evidence for where the tumor is and what kind of tumor it might be, then metabolic therapy will be used to either eliminate that completely or bring it into a dormant state based on you and how you respond to that, not based on some thousands of people, dumped into some trial, all treated the same way by unknowledgeable people. And therefore, you're not going to get the outcome that you would have expected. So it's an educational mission. It's people have to learn. Like you said, how is it possible that you go to oncology clinics and they're giving sugar drinks to cancer patients? And these guys now will run a clinical trial on metabolic therapy while they're feeding their cancer patients sugar. This makes no sense. So again, you have to have the knowledge basis for this. I have one colleague from Norway who had some sort of a skin cancer, and he was able. He had a big. I was invited to Oslo to give a lecture there, and he was telling me that he could actually watch his tumor grow and shrink depending upon his blood sugar, about the blood sugar in his body. So when we're interested in killing tumor cells, we have to simultaneously hit both of the fuels simultaneously. And this is where drugs and diets are used in a cocktail that will selectively remove both glucose and glutamine while transitioning the entire body to nutritional ketosis. People need to know human physiology. People need to know basic biology. People need to know evolutionary biology. So it's an educational mission. But I'll tell you, when you know what to do and how to do it, it works.
It sure does. I know Pablo Kelly is one of many living examples, right? Can you just tell us a little bit about him?
Pablo Kelly came to me in 2014 hearing about some of our stuff. And I have to be honest with you, in 2014, we did not know that much about targeting glutamine in living people. But we knew that from based on our work, preclinical studies, we knew that calorie restriction, water only fasting, could reduce the inflammation and abnormal blood vessels in tumors, could potentially kill some of the tumor cells by programmed cell death, apoptosis, and also necrosis. And Pablo was kind of came from a holistic family in Devon, England, and they didn't want any toxic drugs anyway. So he wanted to, interestingly enough, you can email him, he wanted to have a family. And if they were going to do radiation, he might not be able to do that. But they told Pablo he was diagnosed with a glioblastoma, IDH1 mutation. And they said if he didn't have radiation and chemo, he probably would not last 1 year. So he chose not, he threw caution to the wind and said, I'll do metabolic therapy rather than this toxic stuff. And they all said, well, you're going to be dead. They gave him terrible prognosis. They even tried to strap him to a table and irradiate his head. And he had to tear the thing off and run out of the place to save his life. You can ask him about that. They chopped off his beard and they put some head thing on him. And he says, I just came in for a consultation, and they strapping him to the table. So they were very upset by the fact that he chose not to do their therapy. And he went on metabolic therapy, and he had it inoperable. So his tumor was considered not operable to remove it. So that's why they wanted radiation and chemo. And he said no. And then we put him on metabolic therapy. He did it himself, basically. He measured the blood sugar every day, the blood ketones every day. And I didn't hear from him for a while, for maybe over a year. And then he emailed me, and I said, "Oh, I'm so happy he's still alive." Apparently, they said he was supposed to be dead, and here he is emailing me. We monitor for 5 years blood sugar and ketones in this guy. So we had 5 years of constant measurements, and we were able to show that when he kept his glucose ketone index low, the tumor grew very, very slowly. And when the index went higher, the tumor started to grow again. He's out now 10 years of survival. And he's married, he got 2 children, and And his tumor, he's not cured, but he's alive. And he's living a quality of life. He has a family he never had. And so metabolic therapy does not guarantee a cure, but it can certainly allow an individual to survive far longer than what the was predicted based on standard of care. So yeah, Pablo is happy to talk to people about what he's done because a lot of people say, I don't believe Pablo. Because anybody with a GBM, it's very rare that you would live. But that's one of many examples. I'm starting to see people now. If patients can avoid radiation for brain cancer and do a good metabolic therapy with glucose glutamine targeting, they can live much longer in general than the guys that get the radiation and chemo. That basically, when you irradiate somebody's brain with a brain tumor, you free up a large amount of glucose and glutamine. The two fuels that are driving the dysregulated growth are created in abundance by the very treatment that the patients are given. And this has to stop. People need to know this. They need to know that the standard of care will accelerate the rate of growth and lead to their demise for over 90% of the people with that kind of a tumor. And we have the evidence to support that. And despite the evidence to support that, and despite all of what I'm saying, almost everywhere in the world, Sweden included, brain cancers are irradiated, even though we know that it's going to contribute to the two fuels leading to the dysregulated growth. Now, you have to tell me why they don't understand that. That's the big question. How is it possible that you don't understand this? And when you ask these guys, they said, I never heard about this. I didn't know glucose could drive tumor growth. Oh, if this were so important, I would have heard about it in medical school. I mean, they always give you some non-scientific answer as to why it's lack of knowledge. The bottom line is lack of knowledge. So when you irradiate somebody with a brain tumor, you lack knowledge. It's just that simple. And the evidence to show that your patients aren't going to do well is there. And if you don't read the literature, then the outcome is going to be pretty good predicted. That patient is not going to survive more than I think now it's like 15 or 18 months of survival, which isn't much different than 1926. So survival with brain cancer today all over the world is what it was 100 years ago. No advance in brain cancer in 100 years. Can you believe this? And yet they still use the same thing over and over again. So yeah, something has to change because we're not making any progress, and people need to know all this cancer is a mitochondrial metabolic disorder. And then once people know this and look at the science and get rid of the dogma and the brainwashing that they've had, they'll start to realize what I'm saying, and they'll start to make changes. And the ultimate outcome will be people living with cancer longer at a higher quality of life. That's an absolute guarantee.
I would like to hear some more about what your thoughts are on the standard cancer treatments, and not only radiation, but also chemo and biopsy and so on.
Well, as I mentioned, the reason we use these powerful poisonous chemicals is to stop DNA replication. And if you look at many of the poisons that we use, your hair falls out, your gut is damaged, and you're trying to kill cancer cells by damaging the DNA. The DNA in a cancer cell is already damaged, and then they have other poisons that block the cytoskeleton of the tumor cell, so it can't proliferate. But then your hair falls out, your gut gets damaged. So as I said, my view of cancer is when I see someone with a bald head because they lost their hair, I know that they were treated by someone who has no understanding of the biology of the disorder. Because if they understood you're trying to kill cancer cells do not live in hair follicles. So why would your hair fall out? So again, this speaks to the lack of knowledge on the field. And as I said, the reason why we continue with these toxic treatments is because the gene theory never provided this precision medicine targeting. So the hot topic now is immuno-oncology. So this immuno-oncology is what which is all based on the somatic mutation theory, the gene theory. So cancer cells are supposed to have abnormal genes that produce abnormal surface molecules, and the immunotherapy is supposed to come in and target those cells. The problem is they sometimes will target the cancer cells, but they also see something on another normal cell and target that as well. So you can die from these immunotherapies faster than the cancer will kill you. So and this is another statement of lack of knowledge. So yeah, the standards of care today are based on ignorance, lack of knowledge, and there we continue to perpetrate this hostility on the body of the cancer patients, because I can tell you most cancer patients are not enthusiastic about being treated with anything toxic to make them sick. Why are these patients getting so sick? Why the hair falls out? Why mucositis, bleeding gums, microbiome destruction? All of this is based on the lack of knowledge of the biology of the disorder you're treating. The problem is it's a worldwide lack of knowledge coming from the governments, the pharmaceutical industry, and the academic industry, all participating together in perpetrating a therapy based on the incorrect theory. Now, that's what I just said is pretty powerful.
So let me get this straight. The reality is we are treating people the same way we did 30 years ago, with a treatment that puts people through tremendous amount of suffering, and that obviously isn't even that effective, with the statistics showing more and more people dying from cancer every year. So how can it be this way? How can the medical society be that stupid, in lack of better words? Do you believe money plays a role here, or how can it be this way?
It's what all of what you just said. I don't want to say it's stupidity, because many of these guys are smart. They wouldn't be the heads of hospitals and cancer research centers if they were stupid. What it is ideology, which is an extremely powerful effect on the human brain. Ideology is like religion. Some people of some religions are devout, and there's nothing you can tell that person about switching their ideology to another religion. Politics, religion, they are a way to create a way a brain thinks and analyzes the world based on ideological culture, religion, this kind of thing. And in science, the field has been indoctrinated or brainwashed into thinking cancer is a genetic disease. And an entire industries and systems have been built around this that are extremely profitable for a large number of organizations. And then you come and say, whoa, this is not, all of your system is based on something that's incorrect. And I use some analogies, like the heliocentric and geocentric view of the solar system. For centuries, the Catholic Church thought that the Earth was the center of the solar system. And if you challenged that, you would end up like Galileo and Giordano Bruno, who was burned in the plaza in Rome, challenging the authority and power of the system to say, no, this is not correct, right? So, but it took Copernicus, Galileo, and Kepler to show that it was the sun that was the center of the solar system, thereby making everything seem less complicated than it was. Well, once you realize that it's the mitochondrial metabolic disorder that cancer is, the therapies and the outcome will be so much better than what we have today. But the system is operational in huge revenue generation, in ideology, to think that they are doing good on these patients when in fact they're not. And if you try to stand up to the society, if you try to stand up to the system, you might lose your government supported grants. You may be outcast from a medical school. See, I don't have any of those things. I don't have to worry about that because I don't have grants from the government. I don't work at a medical school. So I'm kind of insulated from that. And don't forget, our research is supported by philanthropy and private foundations. So there are people that want to see this big change happen, and they know it will happen. And there are some people who are not interested in making $1 billion. They just want to know that they're involved in making a major paradigm change. But we have to also understand that the change will be very disruptive, and we have to appreciate how we will integrate what we now know about cancer and how we integrate this into a unified system where we can use some of the standards of care appropriately, because we don't want to throw out radiation and chemo and immunotherapy and all that. Because as I said, if we can use metabolic therapy to shrink a tumor down and you have only a small residual mass, there must be something in common with all those cells. And that commonality could be targeted by either a short dose of radiation or could be targeted by one of these new immunotherapies. So we need to know how the tools that we have, and we need to know how to use them so that we can have an integrated approach to managing cancer. But all of the folks need to know, first and foremost, that this is a metabolic disease, and they need to know how they use the tools that they have currently available with diet, lifestyle, and what we call press pulse metabolic therapy. We've written this all out. We're working on a big treatment protocol as we speak that will be a how-to a manual on what to do and how to do it for various cancer patients. Once we publish that, we'll make it free to the world, and every oncology clinic can look at it and say, I can do this. And you ask the cancer patient, would you like to engage in metabolic therapy? And I find that most cancer patients would like to do that. And then as the tumor shrinks and gets better, then we can move in with some more refined procedures and possibly eradicate the tumor. I'm not, the goal here is, I don't like using the term we cure cancer. No, we manage cancer. The key is managing cancer without toxicity. If you are so lucky to get cured, then be blessed. But most people would like to live longer with a higher quality of life. And I think that represents success. And if you can get that to happen, then you know you are on the right path. And ultimately, this will become the new standard of care, which will be a merging between patient and healthcare provider in a team effort. And the patient will be seeing the effects of their work along with the oncologist. So you'll both be looking at the outcome of the treatment. This is the future. It will replace most of what we're doing as we're doing it today, but it could be considered a disruptive technology, but there are ways to integrate everything together to make the whole system work better.
That's wonderful. And now I'm going to make a statement, and you tell me if I'm right. Cancer cannot occur if the mitochondria in your cells remain healthy.
If you can keep your mitochondria healthy, the probability of getting cancer is much, much less. That's prevention. That's a different concept. Okay. So, and that's a very important question, because cancer can be prevented very easily by keeping your mitochondria healthy. So why don't people keep their mitochondria healthy? Diet and lifestyle. We have a worldwide obesity epidemic. It's now obesity is more common than hunger in the world. Can you believe this? So, and obesity is now replacing smoking as a number one risk factor for cancer. So, if people really wanted to prevent cancer, they would prevent themselves from becoming obese. And the fact that we have an obesity epidemic suggests that people really don't care about preventing cancer. They want to know, I want to eat whatever I want to eat, and I don't want to exercise. And when I get cancer, I want you to treat me with a therapy that is not toxic. So the issue is, yes, we can do that, but it would be better if you didn't have cancer in the first place. So, and that requires us to go back, because don't forget, as you said, in the early 1900s, the number of people with cancer was much, much less than it is today. So what's the difference? What was the difference in that time period versus now? And the answer is diet and lifestyle. So we were workers. We were hard workers. We walked, we worked in fields. Whatever we did, we had a lot more exercise, and we were not eating highly processed carbohydrate foods, unnatural food sources. And you put all that together, and you have an explosion of obesity, type 2 diabetes, dementia, cardiovascular disease, and cancer. So all of this is linked back to diet and lifestyle. Now, people say, it has to be genetic because we have these BRCA1 mutation and all these kinds of mutations that make people, they think it's causing cancer. We did an evaluation of all this, and we found that all of the so-called germline mutations, like BRCA1, P53, and this kind of thing, they all damage the structure and function of the mitochondria. So if they if they damage if the inherited mutations damage mitochondria, then you have a switch to fermentation energy, dysregulated cell growth, and cancer. And we know they're not prime causes because only about 50% of women with the BRCA1 develop breast cancer. What about all the other 50% or 40% with the mutation that never get the breast cancer? They only get the breast cancer if the mutation damages the respiration in that woman in her breast or ovary or one of these organs. Very, very clear. So we can reduce risk from inherited mutations by diet and lifestyle. Some movie actresses want to remove their breasts and ovaries as a prophylactic for having the gene. Also, diet and lifestyle will reduce risk just as well. So we know about all this, but your question was essentially related to prevention, and I always use the example. If you are in your diet, and our diet and lifestyle was the Paleolithic period, which preceded the Neolithic period. Okay, the Neolithic period was when our ancestors first learned how to cultivate grain and herd animals, and cities were built around the food sources. But before that, the hunter-gatherer, which we existed as for hundreds of thousands of years, our bodies were built to move, and we're omnivores. We can kill and eat anything that walks, crawls, or flies on this planet. So when we have Aboriginal tribes on this planet that live according to their traditional ways, cancer is extremely rare. And even the zoo animals like the chimpanzees and gorillas and these kinds of things, cancer is extremely rare. And they're in the zoo, but they're eating, and most of those guys in the jungle just sit around anyway, and they munch on leaves or whatever they do. And that's their diet and lifestyle. And it's very hard that we don't see. There's never been a documented case of breast cancer in a female chimpanzee, and we're 98% similar in genetic and protein sequence to this guy, the chimp, this chimpanzee, and here breast cancer is overtaking heart disease in women over 40. So what the hell is the difference between the chimpanzee and the female human? The chimp is living according to his diet and lifestyle, where the human isn't. So when I asked the zookeeper, what would happen if we give chimpanzees donuts and Coca-Cola and pizza? And they said that would be animal cruelty to the chimpanzee. And I said, well, we do that all the time. we have the cancer, the dementia, the heart disease, and the diabetes. And they said, well, if we did that to the chimp, he'd get cancer, diabetes, and heart disease just like we would. So I mean, you can clearly see the linkages here, right? I mean, it's clearly a disease of diet and lifestyle. There's no question about it. So once you realize that, but then you have to ask people, do you really want to do anything about that knowledge? And then you have to leave it up to the individual to make the choice.
What I like about this is that it puts people in power, people in control over their life in some way. But I would like to ask you, and I think I know the answer to this question, but I still would like to ask you, if you were diagnosed with cancer yourself, how would you treat it? Would you do any of the standard cancer treatments, or how would you go about it?
First thing I would do, you do a blood work. You have to get a very, very comprehensive analysis of all macro and micronutrients, metabolites in your blood. You have to see, the blood tells us a lot about the general health of the person. You have to see what's in the zone of health and what might be out of the zone of health. So once we make that determination, and again, many people with cancer who come to be treated also have other issues like type 2 diabetes, hypertension, high blood pressure. They have other markers of unhealth, and we need to know what these markers are. And we have to try to bring these blood markers back in line with something that might be healthy. So, and normally what we do, what I would do, would be a zero carbohydrate diet for about 10 to 14 days. This would be a diet that would meat, fish, small amounts of vegetables. And I would use the glucose ketone index calculator, which we developed here at Boston College, to see how my GKI index goes down, which is the ratio of of glucose to ketone bodies. As you stop eating sugar or carbohydrates, blood sugar in the body goes down, and ketone bodies mobilized from fats begin to appear in the bloodstream. And that already starts to make you very healthy and also puts metabolic pressure on the tumor cells. So once I would get into this metabolic zone and follow as you said, the patient now has the power. They know, and I've seen the problem is healthy people like yourself who look healthy, you can get into these zones very quickly within a 3 or 4 day, 5 day period. The cancer patients have anxiety, and their blood sugar goes up because they have anxiety due to corticosteroid increase makes blood sugar go up. Also, if they've had any treatment at all, any radiation or chemo, it makes your blood sugar go up, and it's very hard to get into the zones of super health when you're being subjected to toxic treatments. So in my case, like you said, I would never start off with any kind of a toxic treatment. I would not start off with a biopsy either, because I know depending on the kind of cancer you have, you can spread the tumor around your body if you stick it. So we would want to not stick the tumor. We would want to see if we could shrink it down first. If it can be shrunken down to a much smaller size, then a surgical debulking or extraction procedure could be used, which would remove the tumor in its entirety. Because we don't want to stick anything and then tell some guy, oh, you have a benign tumor, or you have a malignant tumor. Well, if it were malignant, sticking it could make it much, much worse, spreading it into the lymph nodes and into other organ systems, then making a much more difficult progress to treat, a much more difficult task to treat. So no, I would never do a biopsy. I would shrink it down, and I would follow it with a GKI and non-invasive imaging. I could do liquid biopsy. I could do MRI, PET scans. There's a lot of ways we can look at. And this is what we see in the patients when we treat them with metabolic therapy. The PET scans, the tumor disappears, or it gets small. Everything changes. It's not the same anymore. So you can actually see that. You can see it happening. So and then as you see what's happening, then you make decisions. Do I want to debulk the tumor, or do I want to stay the course and continue to shrink it to see if it goes away? And then we can bring in the glutamine targeting drugs, embendazole, fenbendazole, 6-deoxynorlucine. Now, I'm a scientist. I have access to buy a lot of these drugs because I have access to buying them. Unfortunately, some of these very powerful drugs are not available to cancer patients for reasons that aren't clear to me, because they're not nearly as toxic as a lot of the things we're using, and they're therapeutically far more powerful. So, but I have access to those, and I believe damn well I'd be using them, and I would be monitoring what goes on, and I would do this as long as I could, as long as I could stay alive doing it, and I would be monitoring the whole platform along with my caregiver. Even though I wrote and worked with the guys writing the protocol, I still want to work with my colleagues that are in the clinic doing this all the time. Right? Okay, I treat preclinical things. I could treat myself, and I want my friends to be looking at my blood work. And as a team, we would make decisions together as to what course of action we would take. And I would get the drugs and I would use them, and I would monitor them, and I would look as closely as I can, keeping my GKI down. It's a challenge. And if I were to die from this, despite all the things that I know, at least I know I died from the cancer, not from the poisonous treatment that I would be given by a standard of care by people who have no clue about the biology of the disease they're treating. So again, you have to leave it up to the individual. But if the individual knows what to do and the caregiver has a plan, then what I just said, and we make changes too. It's not one shoe fits all. Some people can't tolerate this or that. So we have to blend what they can tolerate in together to make their life a quality of life. We always have to remember quality of life is important in the management of cancer. We don't want toxicity. We don't want any of these off-target problems. We want to keep that microbiome healthy, the gut healthy, your hair color. You want to keep everything healthy as you can while you slowly degrade the tumor, and that's the strategy that I would do.
Would you do any fasting?
Oh, absolutely. As much as I would hate to do it, I would do it, but only after the zero carb diet. You have to realize if you're on the second floor and you jump from the second floor to the ground floor, it's not pleasant. You probably will get hurt or break a bone, right? But if you use the stairs, you can get down to the same location a lot easier with a lot less problem. So we do zero carbohydrate diet, allows the body to acclimate itself. And then when you do the water only fasting, the change it's walk you're going down the stairs. You're allowing your body to slowly adapt to this new metabolic reality. But if you try doing cold turkey, not eating, just drink water or something, it ain't pleasant. In fact, it's very hard. Most people will say, I don't want to do this. So you have to do it in the right order, in the right way.
If there are people listening to this and are diagnosed with cancer that are curious about this type of treatment, what can they do and how can they approach this with their doctor?
Oh, man, I don't know. You let them try and see what happens. They usually get slapped down. The doctor will say, I never heard of this stuff. This is snake oil. This is quackery. That's the tragedy. That is the tragedy. We don't have clinics that know anything about what I just spoke about, or know very little about it. The patients themselves must start putting pressure on the medical schools and the system, because I can do all this stuff and say all this stuff and have the hard science to support what I'm saying from not only my work, but from Otto Warburg's work in Germany, and others have provided hard science for what I'm saying. And if the field continues to ignore it and don't use it, then there should be an outcry on the part of the patients to say, and besides, when they start seeing Brad and Maggie Jones's interviews with all these so-called stage 4 cancer patients that are doing well, eventually they're going to say, I want to do what that guy did. He was supposed to be dead and he's walking around. How come you want to poison and irradiate me? Why don't you do what this guy's doing? Well, I don't know anything about that. Well, that means you have to change the system. Who's going to change the system? Am I going to change the system? No, the people are going to have to change the system. So people are going to have to demand from now. You told me about the Swedes not being or being very compliant about following the orders of whatever government you are. Very different from what the Americans do out there, that much. Or some other countries as well. But yeah, there has to be some pressure on the system to make the change. And if you have a logical government, open-minded, not controlled by big pharma, then you guys might be the first group on the planet that could benefit from metabolic therapy. If your government is out for your own interest.
Because what the doctors often say about metabolic treatment is that there is no evidence to support it. So what's your thought on that?
Well, why don't they talk to Pablo Kelly? Why don't they talk to all the people that survived and tell them, do you exist? Or do you are you some sort of an apparition? What do you are you a real person? And then there'll be people to I have Pablo and I don't believe it. Well, and what about this guy I don't believe him either. Well, what about that guy? I don't believe it. Well, what the hell don't you believe? What part of the science do you not understand? I mean, this is the kind of, it's unbelievable. It's actually unbelievable when you see this. It's almost like you can't believe it. You don't want to believe it or something. Even when you have the evidence staring you in the face and you have the science supporting why this guy's smiling and looking at you, who should be dead. And he said, well, I don't believe he never had glioblastoma in the first place. And then I said, well, why don't you look at the histology? That's classic says glioblastoma. I don't believe it. Well, what the hell, man? What do you believe? So you're up against mind. You're up against indoctrination and ideology and all kinds of stuff. Even when you have the evidence staring you in the face, you can't believe it.
Professor Seyfried, 1,000 times thank you for your time. This is such an important information that needs to get out there. So thank you for taking your time trying to do just that. If people want to know more about you and your research, where can they go look?
Well, I have a book on cancer as a metabolic disease, on the origin, management, and prevention of cancer, which is selling more now than it did when I first published it over 10 years ago. It's unbelievable. We have private foundations that support our work, and you can see them I acknowledge they go on the web. I have open access peer-reviewed papers. All you have to do is put my name in there and say, let me see his publications. And a lot of what I'm saying, is published. I mean, I have it. I have the evidence published, the science and the patients and things like this. And then you can look at the acknowledgement section, and you can look at who's doing the work. We got guys in Greece, we've got guys in Turkey, we have guys in different places. And you can see the clinics, you can look at them, do a deep dive. Don't believe what I'm saying. Just go out and do your own research on this. Don't listen. You want to listen to, you get all fired up and everything. Go and look at the evidence. And once you have the evidence, then you make a decision as to what you want to do. Don't, if some guy say, oh, no, there's no evidence, you can say, look at the damn work. I mean, this guy's publishing all this stuff. Oh, I didn't see it. Well, what? No, look at it. Why don't you look at it? I can't believe it. Then you're back in the vortex again. You can't seem to get out of it. But yeah, so people, we have a beautiful paper on the press pulse, which is the framework strategy for what we're going to do. We have a protocol that will hopefully be published someday, which will be fleshing out this whole strategy. And we're continuing to do preclinical. Without our preclinical research, none of this would exist. None of what I'm saying would exist. We developed the singular best animal models for human cancer, the ones that are real and natural, not these genetically engineered crazy things that people look at. Get all these big highfalutin science and nature papers and all this cell papers on things that are like created, not natural. And so you have to look at the real evidence. You have to look at the papers. I try to write them. I know you need to have some scientific literacy. This is what I teach in my classes at Boston College, scientific literacy. It can save your life. So you need to understand. Oh, I don't like those big words. And people say to me, I don't know. Okay, then do standard of care and see what happens. So, and then all of a sudden you see how smart people become in a relatively short period of time. They're all of a sudden able to talk on the same level as you because of level of one thing is I want to stay alive and I'm motivated to stay alive. And that's powerful.
It sure is. Thank you so much, Professor Seyfried, and keep up the good work.
Thank you very much. Nice speaking with you.